example 13 is actually a very easy example. We need to determine the mass of air in the room, and the dimensions are given to be 7 meter times 8 meter times 9 meter at 200 kilopascal and at 20 degrees C. Okay, very easy problem in this, so here I give you some time to do this. Pause this video now. Okay, let's see the solution. We need to determine the mass. So air, here you need to remember one thing is that most likely air can be approximated to be a kind of ideal gas in room temperature. And we will use this approximation very often if we would like to get some properties, for example, the mass of air, the pressure of the air, etc. Okay? Because air has a very large portion of nitrogen, and nitrogen can be approximated as ideal gas also. As a result, we will use the ideal gas equation. And because we need to find out the mass, so we will use the so-called mass version of the ideal gas equation. That is P big V equal to mRT. Okay? Also, we need to note that one thing. Here, in our table, the R is given by kilojoule per kilogram per Kelvin. If this R is given by this unit, if you check the dimension on both sides, okay, you will see that this P should be in a kilopascal, okay? So I need to also remind you here, for R, if it has a dimension of kilojoule per kg per Kelvin, then it means that pressure will have a unit of kilopascal. If you have pressure not in this unit, then you need to convert it to kilopascal. So the first thing is that you need to check the unit, whether it's in kilopascal or not. If it's not, then you need to convert it. But here, we have a 200 kilopascal. So in this case, we just copy 200 kilopascal. Okay? And the volume is 7 multiplied by 8 multiplied by 9 equal to the mass. Okay? But what is R? Because it's 20 degrees C, so if we go to table A2, we have a Cass constant here. And because this one is at 300 K, corresponding is 27 degrees C. For 20 degrees C, because it does not have any great difference with 27 degrees C, so we will just take this value for our convenience. Okay? The area will be very small, so 0.283 kilojoule per kilogram per Kelvin. And the temperature is, remember, we need to change it back to Kelvin. Okay. And finally, you will find that the M is equal to 1200 kilogram. Okay. Very big mass indeed. So here I need to remind you one thing. If the R is in the units of kilojoule per kilogram per Kelvin, then if this V is meter cube and this T is in Kelvin, of course this mass in kg, then this P is in the units of kilopascal. It's in the units of kilopascal. You need to remember this, okay? Because whenever you use the ideal gas equation of state, if you do not bear this in mind, then if you always use the SI units, that means Pascal, then you will get a very big trouble, okay? Similar for the case of the specific heat and the constant volume or the specific heat and the constant pressure in the next chapter. Let's go to the next session now.